And if you don't know, check with your neighbor. Maybe they know. And just be aware that I'm not checking your homework. Ms. Wu was giving out stickers for homework in her Chem 11 class this morning. You know how many stickers she gave out? 3. That's really sad. There were 7 people late because it was first period and only 3 stickers. I don't know how many stickers I would give out in this class, but remember, if you were not as happy as you might be with your grade, think stickers. Do you want me to bring stickers? Give you stickers for your homework? I can do it. I'll bring some stickers. If you want them, you can get them. I'll bring them next day. Abbasson, I've got a progress report for you here. And I also have your test, which has been marked.
Oh, yeah.
You can check it out and then bring it back when you're done.
Yeah. Thank you so much.
There you go. And that's your progress report.
Yep.
Okay, what is one of our conversion factors? Particle ratio? Yep. What's the thing that's the same as the particle ratio? Mole ratio. What's the third one? Sorry, what? Molar mass. And what's the last one? Avogadro's number. Okay. So what do we use particle ratio to convert between? We use it to convert between particles, particles of A and particles of B. Mole ratio we use to convert between moles of A and moles of B. What do we use molar mass to convert between? This one literally tells you in its name. We use it to convert between moles and mass. So moles of A and grams of A. Okay, so these ones are, here's our A's, A, B, B. So the first two are used to convert between 2 different substances. Molar mass, you have to have the same substance before and afterwards. And Avogadro's number, what do we use Avogadro's number to convert between? Moles and particles. And again, this is moles of A and particles of A. Thank you. No worries. So particle ratio, 2 O atoms, for example, per 1 CO2 molecule. Mole ratio, for example, 2 moles of O atoms per 1 mole of CO2 molecules. Molar mass, where do we find it? Periodic table, on the periodic table, and it's going to be so many grams per 1 mole. And Avogadro's number, 6.02 times 10 to the 23 what? Is it moles or particles? Particles per mole. You should be going home every night and writing these down until you know them. Okay? If you can't come in here and write them as quickly as I did, then you're too slow. Yeah? Okay, maybe you can't write as quickly as I can. I am a fast writer, generally. Because back in the day, we used to have to take all our own notes, right? But you should be able to write it as quickly as I can. So go home, write it out once, twice, 3 times, whatever, okay? It should become as easy as converting from seconds to hours, right? Because you just know them. You don't have to think about them, all right? Let's go then to, where are we at today? We did some molar mass. Ooh, grams, moles, and particles. Page 47. 1 and 2 step problems. 5.2e. That's weird. I was on page 47 with my grade 9s. Totally different book. That's okay. So we have, I've given you the map. Do I give you the map for all of them? Oh, good Lord. I'm way too nice. Okay, I gave you the map for the first 3. But let's just pretend the map's not there. If I say, how many moles are in 40 grams of water, because it doesn't say what it's moles of, we have to assume that that's moles of water, okay? Now, is that going to be a 1-step conversion or a 2-step conversion? Can we go directly from grams to moles? Do we know a conversion factor between grams and moles? Grams and moles, what do we use to convert? Molar mass. Where do we find it? On the periodic table. So that's going to be a 1-step conversion, okay? Do I need to show you how to do that? I don't think so. It's a 1-step conversion, okay? Number 2, how many grams are in 3.7 moles of sodium oxide? Because it doesn't mention another chemical, you have to assume that this is sodium oxide. We are converting between moles and grams. What do we use to convert between grams and moles? Molar mass. So in order to do molar mass, what do we need to do with sodium oxide? We would need to write how can I find the molar mass of sodium oxide? What do I need before I can do that? I need to write the formula for sodium oxide, yes. Okay, so you would have to say, okay, I got Na plus, I've got O2 minus, and then you go ahead and you do that. All right. Again, we're not going to do that question. I'll let you try it. Now, here, how many formula units, you can use molecules if you prefer, of lead oxide? So how many formula units of lead oxide, lead 2 oxide, which is PbO, weighs 91.32 grams? Are we able to convert between formula units? We could say those are molecules. Can we convert directly between molecules and grams? Is that a possibility? Do we know a conversion factor between molecules and grams? We only know one conversion factor that gets us to grams. What is that? Molar mass. And that converts to moles, not to molecules. So that means that if we've got grams, what do we have to convert to first before we can get to molecules? We have to convert to moles first because we know that we can use molar mass to do that. And then from moles to molecules, what do we use to go from moles to particles? Moles to particles? You need something with a number because we're finding the number of molecules. Whose number? Avogadro's number. All right, do you guys want to try these first 3 questions on your own? Okay, and if you finish them, you can keep going, and I'll come around and check your work and make sure you're going to get full credit for it. Okay? And keep those 4 conversion factors in front of you if you don't yet know them. Here we are. 40 grams. You're starting with 40 grams.
Water is like H2O. So it's one.
I will find you a reaction.
Like this one's in the side. Yeah.
There you go. And the unit is grams per mole. Yeah. You are going to grams. Here.
H2O. It's like
Grams. H2O. Yeah. 2 of them, so that's 2. And then 1 oxygen is 6. We're not talking electrons now, we're talking about mass. Okay, so hydrogen has a mass of 1.
That you have two of them, so that's now in the student. And it also has an outside.
You just place
Six
the list.
students. So it's going to be 18.0,
This is eight.
and the unit is grounds over walls.
And then what can do it?
Now you have a conversion factor that converts grounds and elevations. Okay. Start with grounds.
So should I just put
Yeah.
So it's.
Be careful. Use grounds when
No,
you
it's
can't
like
see
that's
that.
makes me.
Yeah. So, get you an eraser.
Eraser, where are you?
Yeah, one. One.
Let's take a look. Very well. Yes. Okay, your grounds, cancel your grounds. Your updated walls, and you can move Yeah.
This is over one. That's how much.
All right. Just draw lines. Rounds. Yeah. You want to find walls. Why?
I think this one's.
Look at this, say, 18.
So there's like one more. Is it like this about like?
Yeah, and so there's nothing in front of the green ones.
Yeah.
Okay, so this one, this one.
Yeah.
Like one more of each two are there was 18 rooms.
Yeah.
4 rooms.
Yeah.
I was like, how many rooms? It's building.
Are you gonna start? Yeah, okay, for sure. So this looks really good here because we've got rounds on the top and we have rounds on the floor.
This one's still.
Okay, okay. So what we want to do is we want to have rounds on the top and we want to have rounds on the bottom. Okay, so you're
Should I
gonna,
spoke with it?
get rid of your numbers because you don't know the first.
But you didn't.
Don't just, yeah, I know. Don't put in numbers, put in your units first. So. Write your line. Okay, and on the top, you don't want ground because you want to cancel that, right? So grounds are gonna go on the bottom, okay? Grounds on the bottom, and then moles go on the top. And now when you calculate this mass, this is ground over moles.
Okay.
So write that down, just so you have it there.
Should I do it?
So grounds, no, over, because you want it to look like over, right? Now, 18.
Yeah.
Yeah, 18 was the pounds,
Yeah.
and then 1. One goes with and then equal sign. Throw that into your calculator. Yeah, exactly. One more with the friends. Yeah. And that's the answer. Yeah. Yeah.
That's okay, that's okay.
Map there. What's happening?
It's like, I think it's just.
Start.
We're ready to go. I think that's what you're saying. There.
Yeah, okay, so what was on the bottom? Top. Round, high, yes. And now you have bounds of rounds too small. So you're going to put the. Yeah. Uh-huh. Times. There are another finding, because there's another step here, right? And then holds to the number of molecules. So you want to count some moles. Multiply the number. Right, so that's just where you can go. And what conversion factor gets you? The one goes with the mole. If you guys have forgotten, the one goes with the mole. The one goes with the mole. The one goes with the mole. That's like the same. Yeah. So this is like 12. Yeah. Whereas if I said, I don't know, 12 doesn't really make sense, right? Okay. Now. We'll sign. Okay. That's an answer keys. Who needs an answer key? Moles. Who needs an answer key? Moles. There were other people who needed an answer key, weren't there? Answer key for moles? Anyone missing an answer key? There you go. Okay, so this looks good. Okay, now you need to write the formula for sodium oxide. Yeah, yeah, perfect. Yes. And you have to write the formula here so you get the right. Almost right here. Is there one? Okay, cool.
Oh, wow.
Okay, good. That's good. Videos are good. Yeah.
It's like I found.
Okay. I am starting about how many malls are there for the straight if you want to do one step up. Still follow? Yes. Okay. So. Grounds. Yeah. Malls on the top. Okay, and we know that this is 18 grams per mole. So it's 18 goes with the grams. One goes with that. So you're doing still. But this one is gonna let you. Yeah, okay, that's fine. Don't worry. Okay. Yeah, yeah.
Wait, so.
Yeah.
Thanks, you guys.
Yeah. Okay. So there's two innings.
That's just what we have to solve. There's nothing really actually. I mean, all the maps and stuff.
Yeah. Very good.
It's gonna be really hard.
Yeah. Yeah. More. Times. One. In that.
Scroll down, sleep. Oh, there's no chance for this one.
So 1, 1, 2,
So.
yeah.
Yeah, and it's not. It's just. By then, we'll start to go. Same line. So it's like, right, so it's more powerful.
Feeling have a.
This is the one for me.
Flavor. You gotta explain why. Oh, I think.
Yeah. So it's not here.
Yeah, like. I hope it was just, yeah. Right, I bet. How many
Yeah.
Finally, I was just. First one.
Yes, but
I'm trying to figure out how many.
In this many bands. So then.
You take graph, you put graph,
How much of all do you?
this one.
Oh, it's like. So then this.
yeah.
So then, oh, what is that? Is this many? Is how much? So one range wins 2 teams. We have this one.
Yeah, so you go up to 5. So then you get a number like this, but then like you, I think it's looking for. No, I just thought, but don't look at the next one. You just leave it. Go to keep go. This game is so you're going up.
No, it's not.
So this number is like, yeah.
And so now our.
How much you got now? How many years have you had?
And you did it here. Yes. Absolutely. Well, I can't write that. Now you come to the next one.
This is something. So then, yeah, so one of the nuances of saying,
Yeah.
it's like, like this is not even that. But like from what we have, it's like 6.2. Let me try to buy this. I'll see what you're sharing.
So if you look at
See what those are. I'm just
And folks, keep going after the book. Just keep going. Okay?
Yeah, okay, so. Okay, that'll be the because that. And it's just like one. Yeah, which is a 40.0, and all of these are one decimal place, and more amounts should always be one decimal. Add 0 at the end, add 0.0. That's cool. Oh, I get on your call.
One time.
Okay. You have a question? Yes.
I swear it said that, so word things or something. Yeah, what is it?
If it's just on its own, it's neutral. In order to become positive, it's on its own. But no, this is there. Yeah, so let's just see. Like, okay, so. Okay, it's fine.
So like, you think about it. Plus. Imagine when
Oh, my God, it's slow, it's this big, they're all neutral.
so.
Protons, sorry. Yeah, I'm pretty cool. We have to. Yeah. Yeah, so that's because we have now reacted with the opposite. Or reacted with something else is taking the electrons. Well, a Boltzmann reactor. But like, let's say this made with iron. Okay, yes, it's rust. Yeah, it would. So that's why they generally make metals that have like alloys. And alloys will do things like forming like nice like barrier rather than tarnishing. Simple form, but it forms like latte. Yeah. But we're just saying, I'm giving you a chunk of having. Are we just slow? Yeah. Yeah. No, unless it's with something else, yeah. And then it would be cadmium and it would be cadmium oxide. Are we? Hold on. Most of this is just magnesium, Mg0. There's a little tiny bit on the inside that was magnesium oxide, that's Mg2 plus O2 minus. Okay, but most of it's just Mg. Okay, now, how does it become Mg2 plus? Little baby. Acid. Okay, so H plus. Okay. Now H plus can gain electrons from H neutral. Neutral. H2. Bubbles. So that's neutral H2 coming out. Where did the H2 get its electrons from? They got it from the magnesium. No, the magnesium doesn't have charge until it reacts. Until, but when it's sitting there, it's not reacting. It's not reacting. When you just call it magnesium, because it's not really magnesium anymore. It's like the metal that's there is still magnesium. But when it's gone, then it's magnesium. And it's dissolved in the okay, it's a single replacement reactor. What's happening is electrons are going from the magnesium to the hydrogen. That's the simple. Yeah, okay. Yeah. And you can just not think about your burdens. Yeah. Yeah. How's the math going? Math is good? That's crazy answer.
Oh, yeah, no, yeah. Okay. Oh, I didn't see anything out there.
And you can say, how are you doing? You've done them? Okay. Make sure you have your 0 on there. So because all of our molar masses, periodic table all from decimal places, all of my place your molar mass. Okay. That's just staff. That's stupid. This is nice. Okay. Okay, so this one, you're starting with grams and you're asked for molecules. You cannot go from grams to molecules. Perhaps first to moles. Okay, just like you did here. And then instead of 2, you're going to go from moles to molecules. Yeah, although it's less than that. Okay. Now, if you have finished all of pages, if you finish to page 49, you can try 50, 51, 52, 53, 54. Okay? So just keep going. All right? There's some people who are just getting the process, and I want to be able to support them. But if you're happy keeping going, then you can keep going. All right? And I know it's not the most exciting thing in the world, but the faster we get through this, the faster we get out of it. Okay? So keep plugging away. Hi.
Jacob, like when she's laughing, it's like when you were like, oh,
Yeah.
I kind of came because like I kind of respect. Yeah.
How's it going, Adam? You're good? Confident? That's okay. You don't need to fast it. Yes. Okay, so this one. Yeah, there's one more step. So what you're gonna do is you're gonna do all this stuff first. So I have to go from browns to purples. Yeah, so, yeah. Yeah. You want that? Next year. Yes, now, this comes from. Lead and oxygen. There. Yep. Nice. Let's stop, so you're going to two walls. Yes. Yes. Yeah. It's as easy as 1, 2, 3. It's not difficult, like, teach it that way until like 2 years ago. And I was like, for all these years, like this.
Yeah, just you gotta go.
So there you go. Okay. Okay. Yeah. And then you can do for the next one. This one, here to Adams. Okay. Good. Yes, yes. Yeah. 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 Oh, good. Good.
Oh, yeah, it is.
As long as you know where to lie.
I think that's.
Yeah. As long as you know where to lie. Thank you. Okay. Yeah. Yes. Perfect. Perfect. I would like to have a quiz on Thursday, 2 days from now, on ground, moles, particles. Okay? It makes me so happy to have that also that for. I spend way too much time doing that. So I can find that. I don't know it. Oh my God, what did I do wrong? Yeah. I did it twice. It's so awesome. Oh, it's calculated. Okay, okay, that's valid, that's valid. A lot of hours. My dad found it last year.
Very much the same. Is there this? If I was doing some show, then I should still.
Hello. Okay. Romy? Sorry, you know, no, I was. Yes. No problem.
So if anyone is like, I can do all of this and I am bored, I have some interesting Adam stuff if you are interested, or you can just chill. Anyone? Another day? Very good. Did I? Okay, good. Okay. Okay, so you're right down, I don't know how many atoms. There were 80 atoms, right from atoms to moles. Yes, I have. So it must be one step from one. There wasn't. It was here. Okay. So, one gets into more. Thank you. Of course. Is there a lot of atoms? Yeah. I'd like everyone to finish up to page 50, at least. 50? Okay? So homework 47 to 50. And if you've gone past that, that's fine. That's fine. Yeah. Yeah. What is this problem? Oh my God. So we want to fix it. Thank you.